Okay, hi my gems. Today we are going to talk about solving a system of equations using three different methods. So we're going to do a quick review and then we'll try a couple practice problems together and then you'll do a few on your own. Okay, so there are three different ways to solve a system of equations. There is the graphing method, which is best to use if both of your equations are already in slope-intercept form. So that's that form that's y equals mx plus b, where m is your slope, your rise and run, and your b is your y-intercept, so where it crosses the y-axis. You can use substitution method, which is best if one of the equations is already solved for you, either for x or for y. So you'll see x equals and then the whole equation, or y equals. And then we'll take the whole equation and we will substitute or plug it in to one of the other ones. The last one is the elimination method, which is best to use if both of the equations are in standard form. So that's ax plus by equals c. Realistically, on your exam, they won't tell you which one to do, so you have to know which one is going to be the most appropriate for the different problems that you're given. Now, there are three different types of solutions that we can have when we are looking at a system of equations. One solution would be when the two lines have different slopes, but there's one point where they intersect or cross over one another. So in this picture here, you can see it's this XY coordinate point. No solution means that the two lines are going to be parallel, so they have the same slope, and they'll never cross or touch each other. So if they have the same slope, that means there's going to be no solution. And then the last type is an infinite solution. This is where your lines have the same slope and the same y-intercept. In other words, it's the exact same equation. So that would be considered an infinite solution. So keeping all of that in mind, we're now going to try two problems to solve some systems of equations. So my first example one says a systems of equation is given below. What is the solution to the system in the form x comma y? So I want to be really careful because it's already telling me that I need to make sure when I put my final answer, I put it as a coordinate point. Now, if I look at these two equations that I'm given, this first one, this is in standard form. The second one is also in standard form. So when both equations are in standard form, I'm going to come back up here. The best choice to use is going to be elimination for this problem. And so for elimination, all we're trying to do is either get the x or the y variables to eliminate or cancel out. And in order to do that, it's a very, very easy. What I'm going to do is I'm going to take I can either choose to get rid of the x variables or the y variables. Now, looking at these two problems, or two equations, excuse me, I see that the y's both have negative values, and I don't want to deal with negatives. I only want to look at the positive numbers, so I'm going to use elimination to get rid of my x's. That's where I'm going to focus my work. So in order to do this, very easy, I'm going to take the coefficient of the x variable, so the number right in front of the x variable, and essentially I'm going to flip-flop them. I'm going to swap them. So what I'm going to do is I'm going to take this first equation, I'm going to multiply it by 3. I'm going to take the second equation and I'm going to multiply it by 8. And I'm going to rewrite the equations so that I can cancel out my x. So I'm going to start with my first one here. So this is the distributive property. 3 times 8x will give me 24x's. 3 times negative 9y gives me negative 27y. And then 3 times negative 14 gives me negative, come on, work, little friend, negative 42. Okay, I'm going to do the exact same thing now with my second equation. So 8 times 3x gives me 24x. 8 times negative 2y gives me negative 16y. And 8 times positive 3 gives me 24. Now, I've got my two equations. Notice that my x's line up and my y's line up. Notice too that my x's now have the same coefficient in front, which is great because what I'm trying to do is cancel them anyway. So if I'm trying to cancel or eliminate the x variables, I have a positive 24x on top and a positive 24x on the bottom. In order to get rid of them, I need to subtract these two equations. So I'm going to work from left to right. 24x minus 24x cancels out. Negative 27y minus negative 16y, so minus negative really is going to add those together, gives me negative 11y. So be really careful when you put this into your calculator. Negative 42 minus 24 gives me negative 66. And now this is just a one-step equation where I want to get y all by itself. And the only way to do that is to get rid of that coefficient in front of the y. So this is negative 11 times y. The inverse or opposite of multiplication is division. So I divide the left by negative 11, and whenever I do it on one side of the equation, I have to do to the other. I am left with y equals positive 6. Now, that's great. I've got half of my problem completed because I know what my y variable is, but I still need to figure out what my x variable is. Now, from here, you get to take this y variable and plug it in or substitute it into either the top equation or the bottom equation, your original equations. I'm going to choose, it does not matter which one you choose. I'm going to pick the second equation here. And the reason I'm going to do that is because those numbers are smaller. So Miss Damaso is trying to make her life a little bit easier. And I'm really not trying to work with like really large numbers. I want to make my life as simple as possible. So wherever I see a y, I'm going to substitute in my answer, which was y equals 6. So I'm going to rewrite my equation. 3x minus 2 times 6 equals 3. And this is now an algebra problem. So as I go from left to right, I can rewrite this as 3x. Negative 2 times 6 gives me negative 12 equals 3. On the left side of the equation, there's no like terms to combine. So I'm going to move this constant over to the other side, this negative 12. And the inverse of subtracting 12 is, of course, adding 12. So on the left, I have 3x. And on the right, I've got 3 plus 12 gives me 15. My final step is to get rid of the 3. So I divide both sides by 3. And I get x equals 5. So my final answer in the form of x comma y, right, as a coordinate point would be 5 comma 6 because our x value goes first and our y value goes second. Okay, there we go. We just solved a system of equations that will work every time elimination. I always would suggest going with elimination because it's a lot easier. Okay, example 2. Graph each line in the system of equations. Place a point on the graph to indicate the solution to the system of equations. Now, I've got two different equations here, and what I see is they are both written in, again, standard form. But if I want to graph these equations, I need to put them into slope-intercept form, which is y equals mx plus b, right? Where m is my slope, and b is my y-intercept. And so I have to rewrite it in these forms in order to actually graph the equation. So let's take the first one here, do it in two different colors. I've got negative 2x plus y equals 9. And I want to get the y all by itself. So essentially, I just want to move this negative 2x from the left to the right. And I can do that by the inverse or adding on both sides. So I get y equals 2x plus 9. That's going to be the first equation that I graph. And so why don't I graph that one right now? So I've got my y-intercept where it crosses the y-axis is at positive 9. Okay. My slope is the number in front of the x, which is 2. Now remember, for slope, you might have seen slope as change of y over change of x, or you might see it as a rise over run. So it's how much do you go up or down, and then how much do you go to the right or to the left. Now, my slope is just 2, but I can rewrite it as a fraction as 2 over 1. This 2 on top, my rise, that tells me since it's positive, that means I go up 2. Ooh, work. And then my 1 is also positive, which means I would go to the right 1. So from this point, I go up 2 to the right 1, which is like over here. I also can go the opposite way. Instead of going up 2, I can go down 2 and to the left 1, down 2 to the left 1, and so on until I get a really nice line here. 1, 2. Probably went too far. Don't need this many, but you can see, easy peasy. There's my first line. Ooh, that one's very straight. Look at me, Mr. Masso. Okay. That's my first equation. There's my green one. Now, I'm going to do the exact same thing, but now I've got a second equation I need to look at, which is, oh, don't use that color outline. Ooh, okay, which is 1/2 x plus y equals 4. So again, I'm going to rewrite that equation where I've got some space. And to get y by itself, I'm just subtracting 1/2 x from both sides. So my equation is y equals -1/2 x, and the 4 is positive. Now, my y-intercept right here is at +4. So I'm going to come to my graph, put a point at +4. My slope is -1 over 2. -1/2. So -1 means I go down 1. And then the 2, the run, tells me it's a +2, so I go to the right 2. So down 1 to the right 2, and so on. I'm not going to do them all. And then I'm going to reverse it as well. Instead of going down, I go up 1 and then to the left 2. Oh, look at that. Up, down. Notice that my points intersect, or excuse me, my lines intersect at 1 point. And the point where they intersect is the solution to my problem. So this point right here is the solution. So as an XY coordinate, that is -2, +5. So my solution to this set of system of equations, wow, is -2, 5. Okay, there's my final answer. All right, so take a moment, stop the video, and you guys can go ahead and give these types of problems a try.